US Physics Olympiad, year 2019, USAPHO, final round. Problem B3. Pitfall. A bead is placed on a horizontal rail along which it can slide frictionlessly. It is attached to the end of the rigid massless rod of length r. A ball is attached at the other end. Both the bead and the ball have mass m. The system is initially stationary, with the ball directly above the bead. The ball is then given an infinitesimal push parallel to the rail. Assume that the rod and the ball are designed in such a way, not shown explicitly in the diagram, so that they can pass through the rail without hitting it. In other words, the rail only constrains the motion of the bead. Two subsequent states of the system are shown below. Question A. Derive an expression for the force in the rod when it is horizontal, as shown at the left above, and indicate whether it is tension or compression. Question B. Derive an expression for the force in the rod when the ball is directly below the bead, as shown at the right above, and indicate whether it is tension or compression. Question C. Let θ be the angle the rod makes with the vertical, so that the rod begins at θ equals 0. Find the angular velocity omega equal delta θ over delta t as a function of θ. Solution for question A. In horizontal position, both bead and ball don't have horizontal velocity, and bead has no vertical velocity too. It means that only ball has vertical velocity, and we can write what is this velocity using energy conservation. So we have mgr equal 1/2 mv square, and from here we have v square equal 2gr. Now we can think of this motion as a translational motion for center of mass and a rotational motion around the center of mass. Because center of mass moving in a vertical direction and ball moving in vertical direction, there are no horizontal forces acting on our rod, and the speed of ball around the center of mass is v1 equal 1/2 v. So we can find that the centripetal force going to center of mass is m v1 square over r over 2. So that's equal to 1/2 mg. And because this force could be created only by tension in rod, that's the solution in question A. That's the answer for question A. Solution for question B. Now both bead and the ball have no vertical velocity. It means that bead going to the right and the ball going with the same speed to the left. And again, from energy conservation we can find that change of potential energy, which is 2 mgr, that's equal to full kinetic energy for bead and ball, which is 2 times 1/2 mv square. In this position, center of mass is not moving. It means that we have only a rotation of our ball around center of mass with a speed v. So from here we can find that v square equal 2gr. Let's work in a frame of reference our bead. In this frame, our ball moving to the left with a velocity 2v. So it means that it rotates around bit with a centripetal acceleration 2v square over r, which is 8g. So it means that we have equation ma equal t minus mg. So from here we can find that tension is 9 mg. This is correct because a bit can have only horizontal acceleration, but direction of rod is vertical. So that was answer for question B. Solution for question C. Here we can use energy conservation. It means that change of potential energy go into kinetic energy for all construction. If we have angle theta from this rod to vertical, we have a change of potential energy equal mgr multiplied by 1 minus cosine theta, which is equal to translational kinetic energy of a center of mass, which is 2 times 1/2 mv center mass square, plus rotational kinetic energy around center of mass, which is 2m r over 2 squared multiplied by omega square, which finally give us mv center of mass square plus 1/2 m r square omega square. Now let's count what is the relation between omega and the v center of mass. If we have v is relative speed of our ball around center of mass, we have vertical component of this velocity is equal to v center of mass, and also it's equal to v multiplied by sine theta. And because v equal omega multiplied by r over 2, finally we can put all these three expressions to our first equation, and we will get this equation from which we can express omega square through angle theta. That will be this answer. That was a solution for question C.